Okay, so this is the chapter 7 for the 7.4B, which is the surface area of a sphere. Okay, so actually I told you this is the last video, but actually I missed something. Therefore, I will take one more video about this chapter, but actually I would like to tell you that what you need to learn the new stuff will be end of this video. So for the 7.6, the next video, which is actually something about the similar figures, similar solid, then how can we calculate that kind of things? Actually, I will show you in the next video to deal with that kind of things. But something that you need to learn, you need to memorize, I think that it will be ended here. Okay, so you will see that we are now talking about the surface area of a sphere. Okay, then you will see actually there's activities that actually you can do it by yourself, but if 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 you find interested, you can do this kind of things. But actually, this activities is how we can divide this formula to you guys. Okay, if we have a ball, okay, the first thing we cut it into a half, make it to be a hemisphere. Okay, and then what can we do? We just find a kind of loop, and then we just circular this cover fully by the loop. Let's see how many loop that we have to use. Actually, if we fully covered by this kind of loop, then that loop is the surface area of this hemisphere, right? Okay, then we take out this root to here. And then we discover that if we just cut it into a half, become two part of the root. Then we will see that we can put one part of the root, it can be fully covered to the cross-section area of the sphere. Okay, then actually what these activities tell us, it shows us that if we have a hemisphere, then the surface area which represented by the root is equals to 2 parts of the cross-section area of the sphere. That means if this is something that we are very familiar with, which is the pi r square for the area, then the hemisphere should be 2 pi r square, which is actually a doubled, right? Because one part of the root is pi r square. We now get 2 parts of the hemisphere. So actually you can see that the area of the flat surface area is pi r square. This part is pi r square. Then we combine it. This part which represent 2 pi r square. Then the bottom part also the same for 2 pi r square. So actually we will have a total surface area of a sphere with 4 pi r square. Okay, and that activity is actually shown us this formula. We can now conclude that the surface area of a sphere is now 4 pi r square. Okay, so you will see that by using this formula, we can simply calculating the surface area of a sphere. If we have a sphere with a diameter 30 cm, the first thing we need to do, because the formula is using the radius, so we make it into a half to find out the radius first, and then second we just apply this 4 pi 15 square, and then this is the surface area. Okay, after using the calculator, and in terms of pi, you will have an answer of 900 pi cm square. Okay, then actually you can just simply try to do the quick practice 7.18. I think that this is most likely the same to the examples. Okay, so if we know how can we get this formula, and then how can we apply for this formula, and then we can try example 7.19, because it's just like calculating backward. I have the total surface area, and then we find back for the radius. Okay, it's the same thing, but we're just using a formula to find radius back. But something that we need to pay more attention on this. Okay, first, this is a hemisphere. Okay, so don't just directly use the 4 pi r square. Okay, so if we get a hemisphere, the first thing we need to know is that it consists of two parts of surface area. The first part is the curved surface area, which is something that we have did it before for 2 pi r square. And then second part is the base area, which is the pi r square. Okay, therefore you will see that if we get a 2 pi r square for the curved, for the flat or the base area is pi r square, the total surface area should be 2 pi r square plus pi r square. So in total we will have 3 pi r square. Okay, and now we actually finish the part A, and then part B we find the value of r, which actually the total surface area 3 pi r square equals to 780. Therefore, after we change subjects to r square equals to 260 over pi, then we will have a square root of this 260 over pi. Then we will have an answer for 9.10. Okay, so first thing you need to know is we have to pay attention on this is the hemisphere or the sphere. And then if this is a hemisphere, you bear in mind that there consists of two parts, which is the curved and the based. Okay, so you can see for the quick practice, it's just something about the curved surface area. So what should you do? You can think about that. Okay, so the last example for today, you will see that we got a capsule, and then we need to find out the total surface area of this kind of capsule. Okay, so the first time you will see this question, then you will find it very weird, and then you will curious about how to calculating this kind of stuff. But if we look at very details, I think that this is a very good figures to show you this. How to find out this kind of surface area? We can see actually this is consists of two kind of figures. The first in the middle, this is a cylinder, and the front and the back side, this is a hemisphere. So actually we just need to know the hemisphere, how to calculating the surface area, and then how to calculating the cylinder, and then it is all done. So if we know the details about this, the first thing we need to find out, because we know that the diameter of this surface area of this sphere is 4, and therefore the radius should be 2, right? Okay, then because of the whole things is in the length of 15, then we minus 2, minus 2. Therefore, the cylinder is actually 15 minus 4 equals to 11 mm for the height. And then we can see, no matter for the hemisphere or for the cylinder, both of their radius also 2. Okay, now we just need to adding up all their curved surface area together is okay. Okay, because you can see the cylinder, how can we find the curved surface area? Which is actually 2 pi r, which is the circumference, times h. Okay, 2 pi r h is the cylinder's curved surface area. Okay, for the hemisphere, actually we just learn it. So actually this is a half of 4 pi r square. This is actually 2 pi r square. And for this also 2 pi r square. Okay, and then we need to find the total surface area. We just adding these three parts together, and then we can find the answers. Okay, you will see that. I'm so sorry. And then you will see that because I got the r already, so 2 pi r square with 2 square plus 2 pi r with 2, h is 11, and then plus one more 2 pi r square. Okay, so the total surface area you will have is 4 times 2 is 8 pi, and then you will have 44 pi in the middle, and the last one you will have 8 pi again, and then 8 plus 44 plus 8, you will have the answer for 60 pi. Okay, that's all what you need to do. So you will see the quick practice 7.20 is also consists of two parts. The first part is the cylinder, and the second part is the sphere. Okay, so what kind of area you need to add up together, and how can you apply? You can try just reference to the example 7.20 is okay. Okay, let's try all this kind of quick practice and also the consultation corner. Okay, if you find any question, you can find me. And then one more video will for this part, the similar shape. Okay, so I will take one more video about this. Okay, so that's all for today.